In this video, we're going to look at controlling that LED with different inputs. And so first off, what we're going to do is we're going to get rid of this high, and we are going to use a mechanical switch. Now, of course, those push-to-make switches, they haven't got anything particularly impressive inside them. They've just got two pieces of copper, which are connected to different sides of the circuit, that when you press the switch down, they connect. And I'm just making something very similar, a mechanical switch, which is often quite a useful thing on a breadboard when you don't want to wire up a switch. And what should happen now is when I touch those terminals together, I can get the LED turning on and off. Equally well, if I hold them together and then I break them, I can turn it off. So that'd be like a push to break switch, and that would be like a push to make switch. So two different kinds of switch that you can buy on the market. Let's have a look at some more components. So if we take those out, we could also have a look at this other input component that we've got, which is an LDR, which I'm sure you're familiar with. It's a light dependent resistor. So going from the high to row 40 again, I'm going to put that LDR in, and you can see that when I put my hand over here, well, it doesn't quite turn off, does it? It doesn't quite turn off, but it does turn down. But that's not much good. And the reason it doesn't turn off is because even though I'm limiting the flow of electrons, there's still an awful lot of electrons going from high to low. And we almost need to show them another path, another way to get to low, so they're not all going through the LED and not all making the LED illuminate. So what we're going to do is we're going to get another resistor. Now we could use a 1K resistor, but then I don't think the LED would work at all, because then we've got the resistance of the LED and we've got the resistance of the 1K resistor. And so if we were to connect another 1K resistor, all of the electrons would want to flow through the 1K resistor because it's the path of least resistance. And so instead, what we're going to do on row 44, making sure we're all together, we're going to put a 10K. Now, of course, that 10K on row 44 is not connected to row 40. So we need to connect them. And I've got a nice blue cable here. You see that so far? Hopefully you can. I've got a nice blue cable here that I'm going to connect from one to the other. So going from row 40 to row 44. There we go. Right, LED is still on, that's for sure. Let's hope that when we put our hand over, there we go. So now the LED is turning off because not so much energy is going over it, because some of the energy is going through the 10K. So the path of least resistance isn't exactly true, even though there's more resistance here. And therefore you would presume all of the electrons flow through the LED in the 1K. What you've got is you've got some of the electrons flowing through the 10K, but the majority will want to flow through the LED. All right, I hope that has set you up for your next task. That's that mechanical switch, and also using the LDR as like a dimmer switch.